Okay, so let's look at how do we calculate using significant figures. Let's let this load. Loading. Okay, so let's look at how do we calculate using significant figures. When we calculate using significant figures, we want to take into account a few different things. Whoops. When we are adding or subtracting when we're talking significant figures and we're adding and subtracting 2 or 3 or however many numbers, we need to know how to find our answer correctly. So the first thing you're going to do is add and subtract normally. Then you're going to take your answer and round it to the least number of places that in decimal form. So I want to look at how many decimals were in my problem. That's how many, the least number in my problem is the least number in my answer. For example, 5.62 minus 5. So my answer comes out to 0.62. That's what I do when I add or subtract normally. So I subtracted those two numbers, I got 0.62. But that's not correct. If that's where you stop, your answer is incorrect and it will be counted wrong. What do I have to do? I have to look back at my problem where I have 5.62. 5.62 has 2 decimal places, and 5 has 0 decimal places. The rule tells me that whatever the least amount of decimal places are in my problem, that's all I can have in my answer. So 5 has 0 decimal places, so I have to have 0 decimal places in my problem. Oh no, I have my answer at 0.62. How am I going to do this? I have to round it to 0 decimal places. My answer has to be 1. Because 6 has to round that 0 up to a 1. So 0.62 is closer to 1 if I'm rounding. So let's do some practice. Pause your video, practice these, and then we'll talk about the answers. $34.683 plus 58.930 plus 68.35112. When I do my math, is going to give me 161.964. I have to have 3 decimal places. That's because I have 3 decimal places in this. I have 3 decimal places in this number. I have 5 decimal places in this number. That means that my answer can only contain 3 decimal places because 3 decimal places is the least in my answer, or in my problem, sorry. Okay, so 45,001 minus 56.355 minus 78.44. My answer cannot contain decimal places because I have 0 decimals here, I have 3 decimals here, and I have 2 decimals here. That means that when I have my answer, I cannot have decimal places. So my answer has to be rounded to 0 decimal places. 0.003 plus 3.5198 plus 0.0118 equals 3.535. I have 3 decimal places in my answer because this number has 3 decimal places, the second number has 4 decimal places, and the third number has 4 decimal places. The least amount of decimals in this problem is 3. My answer can only have 3 decimal places. 36.01 minus 0.4 minus 15 equals 21. We had to round to 0 decimal places because this first number has 2 decimal places, second number has 1 decimal place, third number has 0 decimal places. 0 is the least amount of decimal places, so my answer has to be rounded to 0 decimal places. So the answer is 21. Okay, well, what if I'm multiplying and dividing? This is a different rule. So you have to pay attention to whether your rule is addition and subtraction or multiplication and division. So when we're multiplying and dividing, I'm counting significant figures. I'm not counting decimal places. So pay attention. If you are multiplying and dividing, don't worry about decimal places. Count Sig Figs. So I want to look how many Sig Figs are in my problem. Use the least amount of Sig Figs in the problem to round to in your answer. So for example, 10 times 8.2 equals 82. So when I'm multiplying here, I do it normally. Always just do your calculations normally. Put everything in and keep it that way until you get to the very end. Even on multi-step problems, keep everything the same until you hit the very end. Then you can do your Sig Fig rule. So 10 times 8.2 gives me 82. 10 has one Sig Fig. One Sig Fig because I have a non-zero digit. I have a trailing 0 with no decimal, so that does not count. So 10 has one Sig Fig. 8.2 has two Sig Figs because 8 and 2 are both non-zero integers, which means that I count them both. So which one of these has the least? 10. My answer can only have one Sig Fig. So 82 has to be rounded to one Sig Fig. How can I do that? Well, the 2 is what I'm looking at, right? Because I need to find out what to do with it. 2 is going to have to look at the 8. I keep the 0. I keep the 8. 82 is going to round to one Sig Fig, which gives me an answer of 80. 82 is closer to 80 than 90. So I'm going to round it down to 80. Let's practice. Pause the video and try these problems. All right, let's talk about how we get these answers. 98.1 times 0.03 equals, and when you put it in the calculator, you get this answer. I got this answer, but that's wrong because I have to change this so that it works for significant figures. So when I change this, my answer should be 3 because I'm multiplying and dividing, so I need to count significant figures. Opposite, if I was adding or subtracting, I would have to count decimals, correct? But in this case, I'm multiplying, so I'm going to count Sig Figs and use the least amount. 98.1 has 3 Sig Figs. 0.03 has 1 Sig Fig. That's because my leading zeros here are in a decimal, so they don't count. Only the 3 counts, so I can only have one significant figure. 2.943 is going to round up to 3. Second problem. My answer should be 4.2 times 10 to the second. You could also write 420. This still has the same amount of Sig Figs as this one. It's just not as easily obvious. So why? We need to count Sig Figs again. So 57 has 2. 7.368 has 4 Sig Figs. So my answer can only have 2 Sig Figs because 57 has the least amount. My answer on the calculator would have come up to be 419.976. I need 2 Sig Figs here. So I'm going to look at this and say 419. I need to make that number 2 Sig Figs. So how can I do that? I need to round this so that it has 2 Sig Figs. So 419, I'm going to take that to 420 because that's the closest number. Number 3, division. Here's your calculator answer, but I can't keep that calculator answer. How many Sig Figs do I need? Count my Sig Figs here. I have 4, all non-zeros, so I'm counting them all. All of these are non-zeros, so I count them all. So I have 6 here and I have 4 here. That means I have to keep 4 in my answer. So when I look at this, I need to look at 1, 2, 3, 4. And right here is where my cutoff is. I need to keep those numbers. What does that 3 tell me? It says I'm going to just drop these numbers because 3 is not going to affect my 7. So my answer is 1.977. That would be the correct answer. You give me anything else, it's wrong. Number 4, another division problem. So count my sig figs. If I put this in the calculator, it's going to give me this big O number. What am I going to round to? Well, let's look back. How many sig figs are here? 6.90. That's 3 sig figs because the non-zeros count. This 0 counts because there is a decimal at the, it's a trailing 0 with a decimal. All of these numbers count. So I have 5 sig figs here. 3 sig figs, 5 sig figs. Which one's the least? 3. So 3 has to be in my answer. I can only have 3 significant figures in my answer. So this huge number has to be rounded down to 3 significant figures. If I look at the front 2 numbers, or front 3 numbers, that's my cutoff point. The 3 is going to tell me, oh, well, the 8 has to stay the same. It's not going to move up any. So 2.38 is my answer. Anything else is wrong. So when you do these calculations with addition or subtraction, make sure that your answer goes to sig figs. If it does not, it will be wrong. Pay attention to your rounding and whether or not you are adding, subtracting, or multiplying and dividing. So looking again at our rules. All non-zeros are significant. Always count them. Sandwich zeros are significant. Always count them. Trailing zeros are not significant without a decimal. If you have a decimal point, zeros are significant when they are trailing. Leading zeros with a decimal are not significant. That's how we count our sig figs. But now how do we use these numbers and calculate with them? Addition and subtraction. Always calculate normally on both, either addition, subtraction, or multiplication, division. Always calculate normally. When I add and subtract, I'm counting decimal places, not sig figs. Doesn't matter how many sig figs you have, you're looking at decimal places. Your answer can only contain the same number of decimal places as the least is in your problem. So count decimals in your problem, the least amount in the problem.